the cyclist's weight efficiently. They start by cutting carbon fiber into patterns. These arcs are for half of a side wheel. The technician layers them onto a band of fiberglass in a mold. The fiberglass will provide a good braking surface. He drapes a piece of non-stick plastic film over the mold and adds a silicone pressure pad. He stacks several carbon-filled sidewall molds, each with a silicone pad and plastic film. He wraps a heater pad and a plastic vacuum bag around the stack and activates the vacuum. It sucks out the air to pull the melting carbon fiber to the shape of the molds. He adds an air bladder and metal plate. This applies more pressure as the carbon fiber solidifies into a sidewall shape. The next technician layers material for the wheel rims. He inserts strips of carbon fiber into a long and narrow mold, pushing it into the crevices with the Teflon wheel. He applies strips of carbon to the sides for reinforcement. He adds a resin-based film adhesive followed by more carbon fiber. Using a kind of wedge, he again puts on the pressure, causing the carbon fiber and film adhesive to stick together. He transfers the long layers to a round mold. As with the sidewalls, he heats the rims under pressure to set the shape. He'll get 5 wheel rims out of this one tool. The next technician shapes carbon fiber layers around a metal shaft and flares them out to form the wheel's hub flanges. She smooths the creases, then prepares for the vacuum pressure curing, placing a piece of non-stick plastic and a silicone mandrel assembly on top. She stacks the flanges and slides a tube around them. She bolts on a lid. Then it's into an oven to bake under pressure for about 4 hours. This transforms each patchwork of carbon fiber into a solid, seamless bike wheel flange. They'll now assemble the wheel. The technician inserts flat carbon fiber spokes into holes in one half of a sidewall. Adhesive and carbon fiber will bond the spokes to the sidewall. He places a carbon fiber patch where the end of the spoke meets the sidewall and tapes it there. With all the spokes in position, he lowers the lid and applies mechanical pressure. The spokes bond to the sidewall and it's ready for the rim. With the help of a locating pin, the technician positions the rim on the sidewall. He also uses this carbon fiber ring as an alignment tool. He places the other sidewall half with spokes attached on top. The geometry is precise for maximum strength and resilience. After another compressed bake, he applies adhesive to the ends of the spokes and attaches them to hub flanges. He places a metal spacer between the 2 flanges for now and tapes the spokes to prevent adhesive from trickling down onto them during the heating process. He adds a piece of release film and a silicone pressure pad. He clips metal splints to the carbon fiber spokes to support them through the cure. And with the spokes now pressure bonded to the flanges, it's time for fine-tuning. The technician locks the bike wheel in a fixture that stretches the spokes slightly. This creates the necessary tension and rigidity. Once he's satisfied with the tensioning, he applies resin adhesive through a hole in a hub flange. 2 hours in an oven sets the tensioning, and he removes the wheel from the fixture. After cleaning and the application of graphics, the carbon fiber bike wheel just needs a rubber tire, and it's ready to go for a spin.
We really do believe in investing in training, and we set ourselves apart from a lot of our competition because of that.
If I wanted to clean the inside of my heat exchanger, how would I go about doing that?
It's really unique. I mean, not a lot of companies have an in-house training room like we do.
TF O'Brien has always encouraged us to stay on top of our game. You can